Hi, I'm James Ramsey, Group Product Manager here at GitLab, and this is the Gitaly 12.9 kickoff for the release that will be coming out on March 22. So there are two major projects that the Gitaly group is working on at the moment. The first of which is high availability for Gitaly, the very first version of this that we've been working on for quite a while. Over the last releases, we've been working on getting an early iteration of this into GitLab.com's production environment to start testing. And so in October, we got the first version into our staging environment. And then most recently, in late January, we started observing replication in production. So we've been working on this a while and making good progress. And in GitLab 12.9, we hope to release an alpha version of Gitaly HA that our customers can start experimenting with. And this is a rough diagram of the architecture that will be supported in the alpha version. And I'll make some explanatory notes along the way as I'm explaining this about the design decisions we've maybe made as part of this first iteration. So all Git traffic from the Git command line and Git tools over the Git protocol are terminated by GitLab Workhorse and Shell. And then other Git traffic comes from the application that is showing Git data in the repository view or merge requests, for example. And so today those requests go directly to the Gitaly nodes. And in the alpha, we'll be implementing, we've already implemented, but we'll be making it available in an alpha state, this prefect, proxy, and router. And what this does is it maps the requests, takes the requests, and then directs them to the primary, and then manages replication from the primary to the replicas on an eventual basis. So the write will be accepted, and then after the write has been accepted, it'll then be replicated asynchronously to the mirrors. And so this means that if a failure occurs, prefect, which is the router, will handle that failover, detect that the primary is down, and then choose one of the replicas to become the new primary. This favors availability or uptime over consistency because it's eventually consistent. If there are unreplicated changes to the replicas, those changes will be lost from the server. So this is definitely not the final solution. And actually, if I go back to the MVC, you can see that by the time we reach general availability, which we hope to do by 13.0, the architecture will be more sophisticated, but still on an eventually consistent basis. So ultimately, what we're aiming to get to is having multiple prefect proxies. So the prefect proxy can go offline, and an alternative one can pick up, and they can be run in parallel, just with a load balancer in front of them. There'll be a database for tracking the replication queue in the alpha that'll be in memory. And so if prefect restarts or crashes, the replication queue would be lost. So we actually plan to add this database in the beta stage, which we will be working on in 12.9. And then the introduction of console as part of the architecture in the final sort of push towards GA will help us manage leader election across the Gitaly nodes when a failover occurs, keeping track of that so that we can have multiple prefects. And at this point, all the components of the HA architecture are highly available. I would suggest, if you're interested in this, taking a closer look at the epic, which has got some more information about the design, and also in the alpha epic, which explains a little more about the failure modes which are present in the alpha. And also, if you read the epic for the GA version, which can be found here by clicking on this link here, general availability, it'll describe the shortcomings that we expect in the minimal generally available version. One of the primary shortcomings of the MVC, generally available version, which we're working towards, is eventual consistency. Our long-term goal is not to be eventually consistent, but to be strongly consistent. but we wanted a foundation to iterate off of. So today, the architecture looks a little bit like Geo, where you push something and then it's replicated asynchronously to a replica, but there's a different architecture internally. Prefect manages that replication today, and in the future, Prefect will manage transactions. And so what we hope to do in 12.9 is start investigating and ideally implement a proof of concept for what transactions could look like. There's a lot of different RPCs that GitLab uses to communicate with the Git repository, as well as the Git protocol itself, that we need to work out. And so it's important that we start understanding the challenges of three-phase commits and strong consistency sooner rather than later, so that we can have a clear understanding of the difficulty, how we're going to tackle this problem, because we want to come out of the first version, which is eventually consistent, and immediately start running towards a stronger consistency. So watch this space. We hope to learn more about this during 12.9. So hopefully this might even result in some immediately actionable items in the next release, and particularly a clear roadmap for beyond 13.0, beyond the generally available MVC, for when we might get to a strongly consistent version of high availability for Gitaly. So that's the first and most significant focus of the Gitaly team in 12.9, continuing to work on getting high availability ready and in production so that we can start iterating towards strong consistency. This is important for lots of customers, and we're treating it as a top priority. The second item that we've been working on in the back burner for quite a while, and it's a really great, a really great feature, is improving support for enormous repositories. If you've been following the mailing lists or other media about Git, you may have heard of partial clone. We've been contributing to the work of partial clone, which makes working with larger repositories easier. By allowing you to selectively clone data rather than cloning everything. So if you've got a massive repository, partial clone means you can say, I only want to download some of that. Don't give me the large files, only give me the small files, and then download the big ones on demand. Or alternatively, you can also scope these partial downloads by file path. So you can say, actually, this is a mono repo. I don't need the backend code because I'm a front-end engineer, and we actually can run some sort of demo app of the front end without needing all the back-end components. And so you can work with a smaller repository, smaller working copy, and improve performance. So this is in an early experimental stage. It has to be enabled by an administrator using a feature flag. But one of the key challenges we want to address, particularly for system administrators, is if large binary files are being added to a repository natively, like committed and pushed, not using LFS, but using native Git, the storage requirements on the server are going to grow really quickly. And currently, all the files get stored together on the disk, which we would recommend a solid state hard drive for performance. But they get stored in your main block storage attached to your Gitaly server. And this is probably not ideal if you're uploading gigabyte-sized binaries, or you've got a long history in your repository, and you've got all these old binary files, and maybe they're only 20, 100 megs, but they quickly accumulate to hundreds of gigabytes. If you don't need access to those all the time and you're using partial clone, you probably want to offload those off expensive block storage to a cheaper object storage alternative. And so one of the things we're working on is adding dumb HTTP driver support for promises. So there's a smart Git protocol and there's a dumb Git protocol. And the dumb Git protocol really allows you to just use a simple HTTP request, say, get this object. You don't have to negotiate haves and wants. You don't have to go through the usual rigmarole of the Git protocol, which is good most of the time because it makes Git faster and more efficient, less data gets transferred. And yeah, it's ideal for most use cases. But if we're wanting to offload large, big individual files object storage, having the support for promiser remotes, which is part of partial clones implementation, that use the dumb HTTP Git protocol will allow us to offload some objects, hopefully, to object storage while leaving the commonly accessed small objects on a fast, high-performing storage medium. So this allows systems administrators to transparently separate the storage of big files from small files. And this is really exciting if we can make this work. So this is one of the things that we're working on at the moment. There's other improvements coming to partial clone on the mailing list. So watch the release post for those. We're collaborating with GitHub and Microsoft and other parties who are working on this. So partial clone and fast checkout are really exciting improvements to Git, and we're doing our best to support them and contribute to their development as this space evolves. So those are the two main initiatives that we're working on the Gitaly team, both very exciting. Gitaly HA is the top priority and most of our effort is going there. And I'm looking forward to updating you on our progress in the 12.10 kickoff, which will be next month. Thanks for your time.